Okay. So up to this point, there is no difference between LTE and 5G in a way. These are channels which are available in LTE also. These are channels which are available in 5G also. And their usage are also for the same purpose. Their purpose is same. How they are implemented is a little different, which is beyond the scope of this particular program. We'll have a special focus on the physical channel. Then we will discuss there. But the implementations are different, but the usage is same, right? But in 5G, what we have is signals which are totally different comparing it with LTE. Some of the signals which are used, physical signals. Okay, now let me first tell you what is the meaning or the difference between a signal and a channel. So channel is something which has got some relationship with the higher layers. So these are physical channels. They will be connected with the MAC layer, which is further connected to the RLC, which is further connected to the PDCP, etc., which is further connected to SDAP, etc. But so some channels end up at the MAC layer only, like PRAG. Some channel goes beyond that, PDCP, and then etc. But the physical signals, they have relevance only in the physical layer. That means there is no meaning of physical signals in the MAC layer. There is no meaning of physical signals in the RLC layer. So this is basic difference between the signals and the channels. Now, what is the purpose of using the signals, right? For example, we use PSS and SSS, the primary synchronization signals and the secondary synchronization signals, in order to perform cell synchronization, cell sync, right? Okay. So what is cell synchronization? In order to get connected to a cell, you need to first know about its time and frequency. You need to be in sync with that. So for that purpose, we make use of PSS and SSS signals, right? Then we have demodulation reference signals, which are used for PDSCH and PBCH. So this is the reference signal, which is something similar to what we used to have it in our normal LT, called cell reference signal, CRS. In case of 5G, we don't make use of CRS at all. So we make use of DMRS. Now, let me tell you what is the difference. If I tell you CRS, so cell reference signal will be present throughout the bandwidth. And do you know it can have overheads up to 14% in case of 4 antennas. That means the user equipments need to measure a huge amount of bandwidth for the user to identify the channel estimation, right? So first of all, we need to understand what is these reference signals or demodulation reference signals or cell reference signals are used for. They are used for channel estimation. Okay. So what is channel estimation? In simple words, channel estimation is estimating the channel. That means to identify the power of the channel, called RSRP, and to identify the quality of the channel, called RSRQ. So to calculate both of these, you need reference signals, right? So this is same in case of 5G and LTE. But now what is the difference is that in LTE, you perform channel estimation throughout the channel bandwidth. That means if I'm using 20 megahertz of channel, I'll be measuring the entire 20 megahertz and then identifying what is the RSRP and RSRQ going to be. But in 5G, we have a concept of bandwidth part. also known as BWP. Now there are different UEs, UE1, UE2, UE3. Some of them wants to just make use of a small bits, right? Because he is an MMTC user, right? So he's going to make use of IoT based services. So why do he need to measure the entire bandwidth? So if he measure the entire bandwidth, there will be overall 14% of the wastage, which is a huge amount of wastage. The UE battery will also be impacted. So to overcome these issues, they have introduced the concept of bandwidth part, like initial bandwidth part, common bandwidth part, etc., and a dedicated bandwidth part. That means for every user, right? The concept of bandwidth part is very simple. It means if a user needs a smaller bandwidth to be accessed, we will give him the access only on the smaller bandwidth. But if he wants to make use of EMBB services and he wants to make use of a huge amount of bandwidth, in that case he will measure huge amount of bandwidth. So with the help of demodulation reference signals, you can measure how much channel that you are going to use. You will measure or do the channel estimation only on that particular channel, not everywhere else. You understand? So out of 400 megahertz, if a UE is getting an access only on 4 megahertz, he will make use and he will do the channel estimation only on that 4 megahertz, right? So this is the purpose of the bandwidth part. And to identify your bandwidth part, what it's RSRP and RSRQ, we make use of demodulation reference signals. So wherever you have data, wherever you have PBCH, in those cases, you will see also the DMRS, which will help you to identify its RSRP and its RSRQ. So in the planning tool also, you will see RSRP for different channels as well, right? SSRSRP, which is also known as. Okay. Then we have the phase tracking reference signal and the channel state information reference signal. These are basically used for the purpose of MIMO, so that you can make use of the throughput even better. And similarly, phase tracking reference signal is also present in the uplink along with the sounding reference signal and the demodulation reference signal, which has the same purpose of doing the channel estimation. Physical phase tracking reference signal is used for MIMO, and then SRS is used by the scheduler in order to perform a better scheduling, right? So SRS is measuring the part of the spectrum in a way that will help and guide the base station to allocate the user in an area where he is experiencing a better channel quality. So this is what it means. So now we know all the channels: PDSCH, PDCCH, PBCH, PRACH, PUSCH, PUCCH. We know different types of signals, and that's what we have in our chapter 1. I hope you understand all the concepts which I try to explain. If any problem is there, you can write me a message and I will get back to you. And we are also planning to have a one-on-one session for the people who have registered with us initially. So we will see you soon in chapter number 2.